Hey, Math 098, we're going to start in Chapter 10, conic sections. What we're actually starting with is the parabola, as well as the circle. So first of all, why do we call it conic sections? It's based off of the phrase of a cone. And what we are going to examine are the different kinds of ways that we could slice open a cone. Now, if you notice the third one, we have a cone sitting on top of a cone, because that's when we talk about a hyperbola. I'm not quite sure why I wrote it that way, but anyway, we've talked about parabolas before. That's what this first one is, a parabola. And I like this visual. It's one of the first visuals that showed up for me. Because it gives you an idea. If you were to take a piece of paper that was razor sharp and you could slice through the cone at a certain angle, and you lifted up that cone, you would see the shape of a parabola. Now, when we look at the next one, which is the circle, is a parallel to a base of a cone. So if you use your imagination, you slice through the cone and you lifted the cone up, you would see the shape of a circle. So then, if I were to tilt this paper a little bit, so it would no longer be parallel to the base of a cone, but if you notice it does slice through the cone, that makes an ellipse. That's what this next one is. I guess I didn't really clarify that on a parabola it went through the side and the base of the cone. So that's why we get that parabolic shape. Opposed to this one, it doesn't go through the base of the cone, it goes through both sides of the cone, making the ellipse. And then hyperbola, which is not a hyperbole, that's an English term. Hyperbola would be if we had a conic section that was, I don't want to say perpendicular, but because it's tough to explain perpendicular, but straight up and down. So you have, it's not a parabola, it's a completely different term. It's the hyperbola looks more like that. So in the past, we've dealt with parabolas that were functions, so it passed the vertical line test. It didn't pass the horizontal line test, if you remember when we talked about that. But now what we'll be doing is we'll do parabolas that would fail the vertical line test as well, which is basically what we're getting at with the next part. So in our problem, so I stole this off the internet. I'm not unique in this. These are the forms that we write parabolas in. Except the book adds the h value, this is the h value, over, or the k value over. So instead of me rewriting these terms out, which I guess I could do, that wouldn't be very difficult, like the book writes it this way: y equals a x minus h squared plus k. And on this one we have x equals a y minus k squared plus h. So your book writes it just slightly different. So what are the difference between the two of them? Well, if you notice this first one, y equals yada 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 squared, this was the function one, so it passed the vertical line test. We've done those before. When you have x equals y squared, this is the non-function, so this would be the sideways parabola. So instead of opening up and down, upwards and downwards, we're opening up to the right or up into, opening to the left. You can't really say up or down for x equals. It's either to the right or to the left. But anyway, when we look at this problem, the fact that it's x equals y squared, that's telling me that it's opening to the right or left. And the fact that it's positive, it's a positive term here, we're opening to the right. So for right now, I'm just going to put at the origin because there's no h or k value, so we're not shifting up, down, left, or right. We're starting at the origin. So what you could do, before I get ahead of myself, you could make x and y values. It's just kind of difficult to explain. Let's see, let's make our x and y this way. Because this time, we're used to putting in values for x. Well, this time it actually makes more sense to put values in for y, like -2, -1, 0, 1, and 2. So I'm doing this to help you understand why it's opening sideways. Because if you plug in values for y, -2 when you square, it's +4, and half of +4 is +2. So if I were to look at that ordered pair, it's right 2, down 2. Now, if we plugged in -1 in for y, squared is +1, and half of +1 is 1/2. So at x is 1/2, y goes down to -1. But if I were to plug in 0, okay, well 0 is pretty easy. 0 squared is still 0. Half of 0 is still 0. So I already had that point written down though, and that's based off of not shifting right or left or up or down. But if you notice, if I plugged in 1 for y, squared is +1, half of +1 is half again. So that's what I mean, is you can have a problem now that fails the vertical line test. And if I did the same thing for y equals 2, you'll see you'll get +2 for x. And we have this function that opens up and to the right. Now, how could we make this? I shouldn't say up and to the right, sorry. It's just opening to the right. So how could I make this parabola open to the left? Well, what if I had a negative in front? Well, if I had a negative in front, all of these x values would turn into negative values. So that's sort of a shortcut that we're talking about. Now, before moving on to the next one, this next piece is sort of confusing. So stick with me. But remember when we did the function one in an earlier unit, we practiced how the vertex was shifted right h units, because remember it's the backwards here, and then up k units. So that's when we did problems like it was a function. Well, now, let's switch to green. When I do the sideways parabola, this time the h is positive. I don't like how that showed up. So if we have a positive value over here, it's a right h units, and a negative value inside is up k units. So it's still hk, but notice that now subtracting inside is up, so adding inside is down, adding on the outside is to the right, and subtracting on the outside is left. So maybe I need to write all those rules down. And I'll talk about A here in a second, but I'm just writing this out. Hopefully you can see this on my screen. Excuse me. That if subtracting k is up, adding k is down, and right here, adding h is to the right, and subtracting h is to the left. Now, the rule for the a value, I should have been writing in white actually, is if a is positive, in this problem that says x equals, then that is opening to the right, kind of like what happened right here, opens to the right. And if your a value is negative, it opens to the left. So very similar to your parabolas that we've done before, but slightly different. So as I'm looking at the transformations on this sideways parabola, because it's x equals y squared, I can quickly look at this and say, okay, well, it's backwards when it's inside, so it should be down 4. And this one makes perfect sense that it's left 1. So my vertex is actually at, and it's still called a vertex, by the way. I guess I didn't mention that earlier. That it's left 1, down 4. And notice that when it's in the parentheses, it is the opposite, and the y value stays with the y value. So that's why it shifted down, because it's the opposite for the y value. And then this is the same on the outside, left 1. And all I really need from you on this one is to recognize that we're opening to the left. Now, a better math teacher might make you give specific points on these, but for my purposes, for our class, this is fine. I think what I'm going to do is pull up Desmos, because Desmos does this type of problem. Graphing calculators will not graph non-functions. So I just jumped to Desmos, just wanted to show you the answer. And notice that if you just click on the graph and put it right here, you can actually see what happens. And maybe if I were a better teacher, I might even make you guys explore a little bit on your own. Oops, I should make that a minus k squared and then plus h, and make a slider for all of these. And you can just see, well, if I have, whoops, this was supposed to say y. That's why it didn't make any sense. There we go. That what happens if I move my a value to be positive numbers versus negative numbers. And you can actually see that -2 opens up to the left. And then you can see, well, what happens when k is positive? And notice that, I guess the way I have it, I kind of have this written backwards as y minus k. That if k is positive, that means it's negative numbers in there. So that's why it shifts up and down. And if you were to actually make k be -4, like it is right here, minus a -4 is the same as plus. And then what happens when we make h be -1? You can see all the transformations that negative h's shift to the left, positive h's shift to the right, and go on from there. So there's definitely some merit to playing around with the graphing calculator. And, well, a graphing calculator will not do this because the graphing calculator doesn't do non-functions, but Desmos will. So there's definitely a benefit to having Desmos, and it's free, so really none of you have an excuse for it. And you can play around with these and come up with the correct answer. Again, I need to see the vertex when you do your problems. I'm about at the end of my time, so if you need to rewatch this, by all means, you're allowed to. And I have a lot more problems I need to walk you through. But make sure you understand that before trying to do these next examples. These are very difficult. I'll show you here shortly. And then we got to get into circles. There's a lot to still do. So this is going to be a long assignment. It's going to be a lot of videos. Let me put it that way. So if you need to take a break, now is a good time to do it. And then we will jump back into exercise 3.